Today I'd like to introduce you to VIA Intelligent Edge Solutions. Before I go into details about the actual products, I'd just like to give a brief overview of where VIA has come from and the direction we're moving in the future. Originally we started off as an IC design house, doing chipsets, CPUs and all kinds of connectivity chips. And then we moved into embedded systems, and finally now we're moving into what we describe as intelligent solutions. Along the way, we've introduced a lot of different innovations into the market, some of which have actually set standards. A long time before other CPU manufacturers were talking about low power and environmental benefits for processors, we introduced the first fanless x86 processor, the VIA Eden. Also, we created the Mini ITX form factor. At the time, it was the smallest form factor available on the market, and it spurred a huge amount of innovation, not just using VIA chips, but ultimately semiconductors from other manufacturers. And now it's millions of different Mini ITX boards available out there. Most recently, we've been moving into intelligent systems, and we can see that as a good example is the world's first AI forklift safety system. What this does, it detects pedestrians walking in front of or behind the vehicle and sends alerts to the drivers. At the same time, it detects fatigue and distracted behavior such as smartphone usage while the driver is operating the vehicle. So the aim of this system is to use AI to boost safety for people both inside the vehicle and outside. What we're doing with our intelligent solutions is leveraging our core technology strengths, starting off with perception. So perception for us is primarily based around image sensors, and we use that perception to solve a lot of safety problems, as I just mentioned, for example, with the forklift safety system. Also, for example, with dash cams for cars, where we can do features like lane departure warning and other detections. Second area is in system innovation. It's one thing to have the AI algorithms, but the question is, the challenge is how to put them out into the field. And what this requires is very innovative system design for different form factors and different kinds of applications. Again, talking about our Mobile 360 line, is we're putting the devices into vehicles. So there are specific requirements there because the environmental conditions can get very hot. The car can move in lots and lots of different directions. So ruggedization is a very important part of that design. The third thing is, once you've collected the data in the systems, what do you do with it? And this is where connectivity in the cloud become increasingly important. Right now, most of our solutions are based around 4G, but I think it's very clear in the next couple of years that 5G is going to take off, and we're working very hard to do that. Integrating the data with different cloud platforms is also a key part of our work. So for example, if you use AWS or use Microsoft Azure or even Google Cloud, we can make it very easy to integrate the data collected on the device to your cloud platform. So with our VIA Intelligent Solutions, we're solving very tough technology challenges in different segments of the market. Automotive is currently our biggest market segment, but we're also launching a whole new range of intelligent industrial solutions and building solutions. And then finally, our intelligent edge solutions. So what we're doing with our VIA Intelligent Edge Solutions is to harness our core strengths in SoC platform design and software development to enable customers to deliver rapid time to market for their new edge or AIoT devices. So here is our new line of AIoT platforms. All of them are based on the MediaTek Genio SoC. They include the VIA SOM-9X50, which we launched last year, and the VIA SOM-9X35, which we launched the beginning of this year. Also coming up towards the end of 2022 is the SOM-9X12, which features the high performance MediaTek Genio 1200 chips. Each board and platform is targeted at different applications. So for the SOM-9X50, we're looking at quite high performance voice and vision applications. It's also got a lot of connectivity put into the board. So for example, connecting to the internet or the wireless is all there. With the SOM-9X35, we're looking more at mainstream IoT applications. And with that, we also provide a starter kit that enables you to very quickly bring up the system and get it running and prototype your application. We're very excited about the SOM-9X12. The performance looks extremely good on the MediaTek Geno 1200, and so therefore we see it moving more towards much higher premium AIoT applications. So here's just a brief comparison of the different peripherals supported by the different boards. Camera is obviously very critical, and so we can support generally up to 3 cameras on each platform. In the case of SOM-9X12, that will go to 4, and so you're looking really at mainly MIPI CSI cameras, but then also USB for certain applications. Beyond that, display is also critical. You kind of generally need dual display, and so we're enabling that through MIPI DSI and HDMI. And then connectivity gets more and more complex as we move forward, and we're starting to introduce, for example, Wi-Fi 6 and gigabit Ethernet on the forthcoming 9X12 platform. So what we're doing here is providing you with I think a very well calibrated menu of different devices that then you can choose depending on the applications that you're looking to build. And here's an example I just mentioned in performance, is that in terms of TOPS performance, the 350 and 500 towards the lower range, but then you can see with the 1200 a huge improvement up to 4.8 TOPS. I won't go into much detail on this, but it is a brief overview of the SOM-9X35 plus the carrier board with the key features. As I mentioned, dual camera support, also dual screen support, and we see it very useful for vision and voice processing. It does also is pin compatible with Raspberry Pi GPIO, and what we're seeing is a lot of customers who prototyped on Raspberry Pi want to transition to our platform for the mass production products. Beyond the actual SOM module and carrier board, we also do provide a starter kit, including a screen with a touch screen, plus a 13 megapixel camera module and speakers and microphone. This reduces development time, it reduces costs, and enables rapid prototyping for commercial, retail and industrial applications.